Okay, here we go. We've got our first video here in the notes for section 2-3, which is our introduction to the unit circle. As we get started, there's a lot of this is going to be review, I think, for a lot of you, but nonetheless, we will go through this as if we kind of are starting back over. So, as it says, unit circle, it says it's a special type of calculator. Really what we're trying to get at is the fact that we can do some really unique things with a unit circle that we can't do with other circles or other shapes. And so what we're going to try and do, I forgot I can't just scroll through here, is let's get started. Two big facts being the unit circle is created from triangles, which is the whole point of learning it, is understanding those triangles. The other thing to know is that once we've learned, and so unit circle, if we can learn things about this first quadrant right here, quadrant 1, then we can apply that to the other 3. I should be using Roman numerals. So there's quadrants 1 there, 1, 2, and 3, and then the last one, quadrant 4. But again, as long as you know everything about quadrant 1, you can apply it to the other 3. So first thing it says, it's kind of more of like a think, pair, share, or observe, but the triangle below is isosceles. So isosceles, boy, we're digging some geometry vocab out of our brains today, and we have to figure out what do we know about an isosceles triangle. First thing we note, two sides are, think about it, two sides are congruent. So in this case, I'm going to look at it and I'm going to say these sides here, they are congruent. At the same time, we then can assume two angles. I'm going to draw this symbol, that's the symbol for angles. Two angles are also congruent. So just knowing an isosceles triangle has those two properties will get us started. In fact, in this case here in our notes, it says there's a special case isosceles triangle where in this one here below, the hypotenuse is 1. So let me label that. 1 unit, right? We don't have inches or meters or anything like that. It's just a length of 1 unit. So what do we know about that? Well, again, it's isosceles. So here's our two sides that are congruent. And here are our two angles then that are congruent. What do we know about those two angles though? Well, what we got to figure out is if those two are equal to each other and the 3 angles combined are 180 degrees, and this is 90 of those degrees, well, we have 90 degrees left, split equally amongst 2 angles. So that means we have 45 degrees in each corner. So that's one thing we know about it. What else do we know about it? Well, excuse me, I'm going to call this I just broke my own rule. Angles are always capital letters, A, B, and C. Therefore giving us side A, side B, and side C. Well, the other thing we know is that Pythagorean's theorem says a squared plus b squared is c squared. Well, c squared is 1. And a squared is, well, a is equal to b. So I'm going to say if a is equal to b, I'm going to just say a squared plus, and I'm going to replace that and say a squared, because a and b are the same. Therefore, 2a squareds equals 1. A squared, you divide both sides by 2. Okay, so a squared is a half. I'm going to take the square root of both sides, and I'm going to say a is equal to square root of a half. Now, what we know about the rules of square roots says, and fractions, says that we can say that a is also equal to the square root of the top divided by square root bottom. Well, the square root of 1 is 1, and the square root of 2 is square root of 2. Now, we can write that in a more simpler form. Not simpler, more rationalized form. My apologies for that. So just noting, those two are equal statements. 1 over the square root of 2 is equal to the square root of 2 over 2. So there is a more correct way of doing it by writing it. And I say correct very loosely, like in quotation marks. So anyways, that's all we know about this triangle, but that's quite a bit. So the question then becomes, if I reflect this triangle here about the vertical side, this vertical side kind of on the right of the original, if I reflect it across that and make a bigger triangle, because we're going to share that side, what do we know about this triangle? Well, we know that this side is 1. And if we flipped it, so that side is 1. So now this is congruent to this. And well, we know these two here are congruent because, again, we just mirrored it across. This angle didn't change, so that's 45. 45. And 45. Whew, all sorts of 45s here. The side length here is square root 2 over 2 and square root 2 over 2. Oh, we also know that this vertical line, even though it's kind of like a sub side of the triangle now, because we're looking at the larger triangle all the way on the outside, but this upper vertical side is congruent still to those bottom. Well, let's see. If we have, look at this as like half of the square root of 2 over 2, and we have another half of the square root of 2 over 2. When we combine square root 2 over 2 plus another square root 2 over 2, what we have, I'm going to change the color. The entire side length across this is just the square root of 2, because we look at it as like half of the square root of 2 and half of the square root of 2, we get a whole square root of 2. This side length to this side length we're not going to leave alone, but what do we notice about right here? 45 degrees and 45 degrees. Well, that means that the entire, I'm going to thicken that line up. That means that this entire angle here is a right angle. Ha! Now we have side length 1, side length 1, side length is square root of 2, and here is now our 90 degrees, and here's 45 and 45. So really what we've done is we've just created one really large right triangle. And what we also could do, we could have noticed that this is one right triangle. We can say, a squared, so here's let's A, B. I better do this. C again. So a squared plus b squared is 1 squared plus 1 squared equals c squared. So 2 equals c squared. C therefore equals the square root of 2. We just checked our math against this math, but we still get the same thing. So I think that's about it. Yeah. So what we have, okay, right down here, I'm going to add one last note. We'll call it blue. It says special right triangle 45, 45, 90. The thing we want to add in here then is simply a picture that says the hypotenuse is 1. These are 45. And these are the square root 2 over 2 and square root 2 over 2. So a special right triangle that we are going to need to know and use in the unit circle is seen here. And this will get us through our first video. And the next one up, we will be looking at another special triangle, radius 1. So hang in there. We'll continue in our next video.